Hi, welcome to the Center of Excellence in Autonomous Mobility established at Manipal Institute of Technology in Bangalore. The Center of Excellence focuses on developing new-age automotive technologies in the verticals of autonomous mobility. The Center of Excellence has been established in the plan of 3 phases. In the first phase of the lab, we have the equipments and hardware related to sensors and perception with respect to autonomous mobility. In the next phase, we will have controls, mechatronics, and architecture and validation as well as we gradually go in next 3 years. Let me give a quick walkthrough. What do we have in this lab at the Manipal Autonomous Mobility Center of Excellence? So the 5 of these equipment which you see here consists of all the variety of sensors that goes into any advanced level autonomous mobility vehicles. So let me start with this setup that we right now have here. So we have the Ouster OS1 3D LiDAR, we have the MLID RS2 GNSS, we also have the complete set of ZED-based cameras, that is ZED-X1 and also ZED-X for the sensor perception activities. We also have the NVIDIA-based controller platforms where we will be able to do all the computational activities. The whole setup can now evolve to work just with a one sensor or utilize the variety of other sensors to take care of the fusion activities. The fusion can be done through multiple cameras, or fusion can be done with multiple cameras and the depth sensor camera, or also combining with the LiDAR as well. So any industry grade autonomous mobility vehicle will have similar of these sensors. So we host such sensors here so students can learn at an individual level and gradually build on top of it to work with sensor fusion and other activities. Apart from our main sensor fusion kit, so we have the micro sensor fusion kit as well. In the micro sensor fusion kit, we have the Livox 3D LiDAR, and we also have the array of 2D LiDARs as well. And then we have the number of cameras, such as the front view, the side view, and the rear view cameras. And then we also have certain monocular cameras. With the help of this complete set of sensors, also along with ultrasonic sensors, students can work on understanding how to use the data, how to work with the data for each sensor, how to connect these things in the ROS, how to take the data from multiple sensors and fuse them together, work on various areas of machine learning, AI upon the cameras. So plenty of opportunities for students to learn through this. Decibels also has developed a unique set of experiments. These are not just, okay, let's just do this and collect data, but completely in a developmental approach so that the students will work with the sensors, work on sensor fusion, or work on even before that, the data cleaning, mapping, and variety of activities that gives them a more confidence to work with real-time products in the future. In addition to these setups, we have the setups for the individual level sensors. This is a camera perception kit, so where we have a variety of cameras, maybe long focal length camera, the wide angle cameras, and then also the cameras which is with a fisheye and edge AI features as well. Also, the stereotype cameras are available here. So individually, students can start to work on that in the beginning, and then come here, work on fusing the data of multiple cameras, or work with other set of LiDARs and other components, so that gives them a comprehensive experience on working with a variety of sensors. In addition to that, the very important part of any autonomous mobility segment is also using the radars. So here in this setup, which is called as Radar Perception Development Kit, so we have the short-range radars, and then we have a long-range radar. We also have the 4D radar, which gives students an experience on how to use the data of these radars, how to utilize that information to identify objects, identify the distance of the object, speed of the object, height of the object, or various other activities. They understand how the communication protocol works with these sensors, and then collect this data in the ROS, and then do a lot of computations to utilize the data for any of the autonomous mobility development activities. Along with this, we also have the LiDAR perception kit. In this one, we only have a set of LiDARs, and it could start with the 1D LiDAR and 2D LiDAR, so they can learn about how to use this data and utilize it in various different activities. Once they kind of get a basic idea of all of these sensors and which are on the other side of the lab, Here we have more of the activities such as the steering angle sensor. With the help of this, how do you precisely read? Maybe let's say if you do a 1 revolution, how much of the precise measurement you will be able to do with the help of these sensors. We also have the 9-axis IMU, how to get the data, how to utilize the data for a variety of application activities. Then students will have a set of robots, like example like this one, and also we have the furthermore the bots which are here in this lab. They can work with a sensor perception and also get an opportunity to apply that skill sets and utilize that information to drive some of these bots which are available here. So these bots are custom developed. Students can write their own software, they can write their own programs and then implement in them and play with them. So to make all of this happen, so we have developed this small arena, we call it as. So it has all the road information, it also has the traffic lights, and it will also have a variety of obstacles and all such things, so that they can just take these bots, implement it here, just get them into a challenge to address like how do I control my bot, maybe line positioning systems, or also with respect to traffic light image detection, stopping, speed limiting, or how to do an obstacle avoidance, and variety of other activities they can do as a part of this setup. So here is a small area for students to do and developing a bit of a tinkering stuff here, and that gives them an opportunity to work with electronics and do a fabrication activities and things like that. So coming to the final section, so how do we going to use this lab? This lab will be useful for students to take part in the open elective programs, or it can be possible for them to take part in the minor programs in BTech. Also, we will come up with a lot of certification courses, evening workshops, weekend workshops, and variety of learning opportunities for students who are studying here. Along with that, we also bring in postgraduate certification courses, which may be length about 6 months to 9 months or 1 year, where the participants from the industry can come here, also get the real hands-on learning experience at a very small component level. Even the graduate with a number of years, we will have a state-of-the-art lab facility, even up to a verification and validation with the Hill test benches and all of that. With that vision, this lab becomes one of the very good and an actively running lab to help the students and industry participants to learn about autonomous mobility activities and development and testing. With that, we look forward to have you learn great things at the Center of Excellence, and you can come forward to participate if you are in industry, if you are from the corporate, would like to participate in any training programs. We are open to take you in any of these courses which suits you. Thank you.